In this video we're going to complete example 2 and we're going to learn how to round numbers to a certain number of significant figures. Now before we get into the example, I want to talk about the two different methods we can use to round numbers. One we should be very familiar with, and that's rounding to a certain number of decimal places. So I'll give a simple example of this. Let's say we have the number 3.2185, and let's say I want to round this number to only one decimal place. So we would write down 3.2 because we only want one number after the decimal point, and we call that rounding to one decimal place. That brings us to the second method we use when rounding numbers, and that's rounding to a certain number of significant figures. If I was to round this number to the same number, 3.2, using significant figures, what would I write next to it? Well, I would actually write that this is written to two significant figures, and the reason for that is I have two digits here, the 3 and the 2. So I guess the difference between these two methods is one focuses on how many numbers you have after the decimal point. That's rounding to a certain number of decimal places. The other method focuses on how many digits we're going to take from the number. So in this example, we took two of the digits, or two of the significant figures. Both methods have their advantages and their disadvantages. The first method, where you round to a certain number of decimal places, is really useful when you just want to focus on shortening the decimal. We do this all the time when we make calculations. Take, for example, using the number pi. We don't want to write down all these numbers here. We just might write it as 3.14, correct to two decimal places. So when is it useful to round to a certain number of significant figures? Well, this is really useful when you have really, really large numbers and really, really small numbers. Let's say I have a lot of money. Let's say I have 1,341,208,001. If I have that much money, there's really no point in me reading that whole number. What would you say if you had this much money? Well, you might just say that you have $1 billion. What's the point in using all the other numbers? Well, I've just rounded this number to only one significant figure. I picked the number 1 because that was the most significant digit out of all the digits here, and I made the rest 0. I might have even decided to round it to two significant figures. I might have decided to keep the 1 and the 3 and make the rest 0. And then I would say, well, I have $1.3 billion rounded correct to two significant figures. So here we can see that rounding using significant figures is really useful when you have large numbers. In fact, we do this all the time. We don't read the whole number. It's also true for small numbers. Let's take, for example, the number 0.000, and I'll keep going for a while, 78129. For this one, I would have to round it. Let's say I want to round it to only one significant figure, and I would actually have to round up. I would have to put an 8 instead of the 7 because the number that comes after the 7 is 5 or above. So we've been able to round this number here to only one significant figure. Now, if I had decided to round this to a certain number of decimal places, it wouldn't have worked very well, especially if someone had said round it to 3 decimal places. I then would have just had 0.000, which is completely useless to me. Anyway, let's get into the example now. So as I said before, we're going to round to a certain number of significant figures. And you'll notice we have some square brackets here which tell you how many significant figures we're going to round these numbers to. We're also going to express our solution using scientific notation. So we'll get to that a little bit later. So starting with question A, I've got to round this to one significant figure. Now, what is the most significant figure here? Well, it's the one furthest to the left, the 3. And the reason for that is because this is actually the largest number. Now, some of you might say, well, isn't 4 bigger than 3 or 7? Well, not really, because this isn't really 3. This is 3 million. And this 4 is really 4,000. And the 7 is really just 7. 3 million is much bigger than 4,000 or 7. So what we're going to do is we're going to keep the 3, and the rest of the digits become 0. And that means that we've rounded this number to only one significant figure. Now we need to express our solution using scientific notation, which is quite simple. All we do is look at our number and go, how many zeros do we have here? 1, 2, 3, 4, 5, 6. So I'm going to write this as 3 times 10 to the power of 6. Now, in case you're wondering why we do this, well, it comes in really handy when you have really large numbers, numbers even bigger than 3 million. I'll give you an example of this. I'm going to write a really large number up above. Now, at the moment, I don't know how to pronounce this number, but I do know that I have 21 zeros. So I could have written this as 5 times 10 to the power of 21, and it just saves me writing all those zeros down. I guess the reason we call this scientific notation is because in science, we get really massive numbers and really small numbers sometimes, and we just need to save time and also save space on paper by using scientific notation. Anyway, we'll move on to question B. This time we're rounding to two significant figures. And the two most significant figures, the ones furthest to the left, are the 5 and the 6. Now, after the 6, you might have noticed we have the number 8, which is 5 or above, meaning we need to round up. So instead of 5, 6, we're going to have 5, 7. So we will write down 0.0000057. Now we need to write this using scientific notation. To do this, I'm going to take my significant figures here, my 5 and my 7. So I'm going to write them down. And whenever you write using scientific notation, you need to have a decimal point after the first number. So it's got to be 5.7. I then times by 10, and I need a power, and this power is going to be a negative power. And the reason I know that is because it's a decimal. So when we have really large numbers, we have positive powers. When we have small numbers, like this decimal here, you have negative powers. The thing is, what number is going to go here? Well, what we're going to do is we're going to look at the decimal point. How many moves did it take for us to put the decimal point between the 5 and the 7? It took 1, 2, 3, 4, 5 movements for us to move the decimal point between the 5 and the 7. So we're going to write -5 as our power. Alright, we'll move on to question C now. This time we're rounding to 3 significant figures. The 3 most significant figures here are the 3, the 9, and the 1. So I'm going to keep those digits, the 3, the 9, and the 1, and the rest of the digits become 0. Now I need to write this using scientific notation. So taking those significant figures, the 3, the 9, and the 1, I need to have a decimal point. The decimal point always goes after the first digit. So it's 3.91. We're timesing this by 10, and we're going to have a positive power. What's that positive power going to be? Well, if you look at the original number, there was no decimal point, which means there technically is a decimal point, but it's at the very end. And I want to move this decimal point so it's between the 3 and the 9, which is what we have here. How many movements does that take? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 movements. That's our power, a positive power of 11. Moving now on to question D, we have to pick the two most significant figures here. That's going to be the 5 and the 9, the digits closest to the left. Now you'll notice after the 9 we have a number that is 5 or above, which means we need to round up. Now thinking of this as the number 59, if I round it up, it actually becomes the number 60. And what happens to the rest of the digits? Well, they become zeros. We're going to have another 4 zeros here. Now when someone looks at this, they're going to think to themselves, it looks like we've only got one significant figure. We've got 6. When in fact, we've actually got 2, and in some cases, zeros can be significant. We started with the number 59 and rounded it to the number 60. So this 60 here is actually significant, meaning the 0 is significant. So when we write it using scientific notation, we have to use two significant figures. We have to write it as 6.0 because the 0 is significant here. So once again, we need to times this by 10, and we need to put the 10 to a certain power. Remembering that the decimal originally was at the very end of the number, and we've moved this decimal point between the 6 and the 0, which takes 1, 2, 3, 4, 5 movements. So our power has to be 5. Now moving on to question E, we're picking 3 significant figures here. So I'm going to underline the 9 and the 8. And this time, once again, we've got a 0, which is a significant figure. So we're going to write down 0.00000980, remembering that this 0 is significant now. Not these other zeros, but this one here. So when I write it using scientific notation, I use those significant figures, the 9, the 8, and the 0. And I need to put the decimal point after the first number, timesing this by 10 to some negative power. What's that power going to be? Well, I want to move this decimal point so that it's between the 9 and the 8, which is what we want over here. So how many movements does that take? 1, 2, 3, 4, 5, 6 movements. So our negative power is 6. Now moving on to question F, we want to round this to only one significant figure, meaning the 9 here. And after the 9, we have a number which is 5 or above, which means it needs to be rounded up. And when we round 9 up, we actually get 10. So we're going to get a 1 over here to the left. So I'll write that down, 0.00000001. So we had to move to the left and round this 0 up to the 1. And now we have only one significant figure. So we're going to write this in scientific notation using that significant figure of 1. We're going to times it by 10 to some negative power. So where are we moving the decimal point to? Well, when we look at the number 1 down here, technically there's a decimal point just after it. So I've got to move this decimal point 3, 4, 5, 6, 7, 8 times so that it comes just after the 1. So we have our negative power of 8 here. Anyway, that concludes our video on example 2. Remember to read the description below for links to workbooklets that relate to this video.